How's it going, guys? Today, this is my girlfriend Carly. Today we're going to be going over a problem called climbing stairs. This is a common interview question on LeetCode that's asked by Google, Amazon, Goldman Sachs, Walmart, Alibaba, LinkedIn, and Microsoft. I never understand why they have Walmart. I don't really know. I didn't really know Walmart had software engineers, but anyways. So the problem description says you're climbing a staircase. It takes n steps to reach the top. Each time you can either climb 1 or 2 steps. In how many distinct ways can you climb to the top? And note you'll be given n, which will be a positive integer, so we don't have to worry about that. So as a quick example, it says if we're given the input of 2, we have to output 2, because there's 2 ways to climb to the top. Either one, we take 1 step and then another step, or the second way is we just take 2 steps. So this is actually a classical dynamic programming question. I actually saw a variant of this question at my during one of my Google on-site interviews. So this is a really good question to know. And again, this is kind of why LeetCode is so accurate. This is a question that I've seen. This is a question that I wouldn't be surprised if any of you guys actually got during one of your on-site interviews. So make sure you guys know how to do this, and more importantly, make sure you really understand why it works. So with dynamic programming, there's 2 ways to solve things. You could solve things top down, or you could solve things bottom up. And I always think it's more intuitive to solve things bottom up. So when you solve a problem bottom up, you want to think about the base case. So in this case, we're dealing with stairs, and we have n stairs. So we want to ask ourselves, okay, instead of n stairs, what if we were just climbing 0 stairs, right? How many ways could we climb 0 stairs? And the answer is 1, right? The one way to climb 0 stairs is actually, Carly, you can move if you need to. And the one way to climb 0 stairs is just you don't climb them, right? So we have that as our base case, and then we kind of build off of that to solve any other larger problems that's not, or rather solve a subproblem that's larger than the current subproblem. So now that we've solved the 0th subproblem, we can solve the problem where we only have 1 stair, right? So how many ways can we climb 1 stair in this situation? Again, it's just one way, right? Not super interesting. We just climb up 1 step. And then, so once we have a basis or a foundation, we can build and try and solve something like dp of 2. And dp of 2 is just saying how many ways can we climb 2 stairs. And then we solve how many ways can we climb 3 stairs and 4 stairs. And then eventually we will have solved all the subproblems, and we can just simply return how many ways we can climb n stairs. So with dynamic programming, we're basically just remembering how many ways, or rather how many the subproblems that we've solved. So we need to make an array to store the subproblems. So we'll have an integer array called dp, and this is what's going to store how many ways there are to climb 1 step or 2 steps. And then eventually, once we've solved the dp array all the way up to the nth thing, we could just return it. So we'll make a new integer array, and because we're going to have certain base cases, we're going to have this be equal to n plus 1. And so the reason for this is just because we know that dp of 0, which represents, again, the number of ways to climb 0 steps, is just 1 way, right? You don't climb them. So now, let's solve dp of 1, right? Which again represents how many ways are there to climb 1 step in our problem. Well, you could just climb 1 step. That's the only way, right? So there's 1 way to climb 1 step. Now, we can actually go through and solve this dp array. So however many ways there are to climb 3 steps up until n steps, and then we just need to return it. So we'll have a loop, so for in I equals 2, because we've already solved 0 and 1, while I is less than or equal to n, because we have to go up to including the nth step, I++. And now what we can do is we can set dp of I equal to however we're going to solve this, right? So we know that we can only take 2 steps at most, which means we could have only come from the previous step. So if this is our step, we had to have come from the step before it or 2 steps before it. So because of that, we know that it's equal to dp of I minus 1 plus dp of I minus 2. And the way this breaks down as an actual recurrence is getting to the I step is as simple as how many ways are there to get to the step that you're trying to solve. Where could you have come from, right? So the only ways we could have gotten to the step that we're at is coming from the previous step or 2 steps before that step. And we've already solved those subproblems. So that's the beauty of dynamic programming. So dp of I is just simply going to be equal to dp of I minus 1 plus the dp of I minus 2, because we've already solved those subproblems. And now all we should have to do is return dp of n, and that should really be it. Let's make sure this works. It does. Awesome. So guys, that's how you solve climbing stairs. This is a variant of a popular dynamic programming question. This is super important to know how to do. If you guys have questions, be sure to leave a comment and let me know. I'll be happy to answer it. If this was helpful, be sure to subscribe. I make a video every day, so you guys can kind of like see a new tech interview every day and kind of help you with your preparation. Again, if it's helpful, leave a thumbs up and let me know, and I'll see you guys next time.